All right, class.
Yes.
Okay, I got like 2 people trying at least. All right, so, okay, good news, bad news. Grades suck. That's bad news. Good news. You have the opportunity to try and bring it up, and it needs to happen in between now and let's say you got 2 more weeks. That's the next progress report. So I'm not going to be doing stuff that we did, now at the end of the semester. So you have 3 weeks basically to try and get things up. So this is the start of week 4, so you have 2 more weeks to actually try and get it in. So trying to work around your schedules and the time to be able to come in and take these. So you have a window now, because I had some people at the end of the semester last semester try to do week 1 homework because you never did it at all. And I'm not going to take that now. So what we're doing is we're trying to get you guys grades up now before the end of the semester and just keep them up, so it's not going to be a problem. So let's take a look at this. So for here, so my notes, this is hashtag 19. And today's date is 1/27. Yeah. 2020. All right, so what we're going to do is says solve each equation mentally. So we have to go through and, what's up? Huh? Yeah, go ahead. Go ahead. And you need to go. You want to get a drink, right? Yeah, go ahead. So let's take a look. Solve for each of these mentally. I want you guys to actually try these out, please, without shouting out answers. So without shouting out answers, you guys are trying some of these. Now, you can use your calculator to try and figure out what the numbers are supposed to be to help you out with this. So I'll give you a moment before I start calling on some people. All right, let's see. Hey, Juan. That one. What do you get for the first one?
Isn't it 25?
Not 25, because that's an exponent. That is correct. 5 times 25 will give me the 125. All right. Let's see. Leba, what do you think? Zoom in? It's on your paper too. It's not 5. Angel, what'd you say?
I said
3. So he's saying it's 3 because 5 times 5 times 5. So 5 times 5 is 25. Times 5 is my 125. So we get 5 to the 3rd power is 125. Okay, so let's take a look at the next one. On the next one, I'm trying to figure out what R is. You say same? Why? So it is 3 because 1 over 5 times 5 times 5 is still going to give me 1 over 125. All right, this is going to be a good one right here. This next one. Okay, because I'm not calling on you. I think I'm calling on Joseph on this one. What you got? Huh? 3? Not 3. Ethan, what do you got? -3. Very good. -3, because the negative. You guys remember from first semester, the negative will make it go down, right? It'll become 1 over. So T is a -3. And this last one here, this is a super good one right here. I think George is going to get this one.
This one?
Yeah.
1 over 3?
1 over 3. Excellent. Okay, because 1 over 3 is like the exponent, so that would be 125 to the 1/3, which is the same as saying the cube root of 125, which gives me 5. So yes, that is correct. All right, so let's see. For this right here, it says population of Nigeria. In 1990, Nigeria had a population of about 95.3 million. By 2000, there were about 122.4 million. Okay, an increase of from about 28.4% during that decade. The population can be reasonably modeled by exponential function. Okay, so now, class, is it increasing or decreasing? Okay, so now let's start off with, if it stays exactly the same, what percent is that? 100%, right? So if it stays the same, it's 100%. But this one is increasing, isn't it? So what am I going to do? Add it. Increase of this. So we start at 100%, right? And this time we're adding a 28.4%, which gives me a total percentage of, that's a 8.4%. There we go. Now, same formula that we have been doing for days. Go ahead. Yeah, go ahead. Same formula. P, R, T. We're going to be doing the same thing over and over and over again. Okay, you're going to have test questions where you're going to have to know these things. Now, P. What does P represent? 95.3. And 95.3 is my starting amount. My initial value is P. So if you don't know that, you need to write it down. P is your initial amount. P is the starting amount. P is the amount that you must start with. So, R. R represents the rate. Okay, whatever the rate is. It's not always going to be percent. It's not always going to be percent, but it will, in this case, be a percent. So R is the rate of change. So if you didn't know that, you're writing it down because R is your rate of change. So my rate of change here, I'm going to write there you go. And we always write our percent as over 100 because it makes it a whole lot easier later on. Now, express the population of Nigeria, F of D, in millions of people, D decades since 1990. So D would represent 1 decade. 1 decade. So what am I going to put right here?
10.
Yes, I put D because it says use D. Did it say what year to find it? Say no. It did not say what year to find it. It says express the population of Nigeria, F of D, in millions of people, D decades since 1990. D will be the amount of decades in time. Say yes. Good. Now let's go ahead. It says write an expression to represent the population of Nigeria in.
So we have to, this time we have to put the years, correct?
Yes, now you're using the year, right?
Same formula.
Because we have that formula, but now I have a year. Not yet. I'm giving people a moment to try and fill this in. All right, let's see. First things first. What am I going to use for my D value here? Not 6. 6 represents what?
0.6.
6 would be decades, right? Is it 6 decades? It's 6 years. And so that's 6 out of 10, right? Or, as a decimal, 0.6. So now that everyone has that part right, let's go ahead and plug it in the calculator. What do we got? Okay. And what are my units here? Million people.
I have 0.7 of a person.
Huh?
700.
Oh,
Yeah, remember these are in millions of people, so that's going to be 700,000, right? Yeah. So if it was people individually, I wouldn't do with the 0.7, right?
right.
Okay. All right, it says a student said the population in Nigeria grew at a rate of 2.84 every year. Explain or show the student's statement is incorrect.
Correct.
It's correct?
Yes, sir.
Okay. So show me why it's correct.
Because by 10, which is a decade, by 1, which is 2.4, 2.84. You know, like, you know how the decade
Yeah.
is growing by 2.4, they divide that by 10.
Okay, so we just took our regular 28, right?
Divided by 10.
Okay. And divide that by
10.
okay. Now let's see if it works, okay? Let's try it. So if we're doing that, then this is going to be my rate, isn't it? Okay, so my total rate would be this plus 100, wouldn't it? So I should have 95.3 times, what's the rate supposed to be here? 1, no, look right here. 1, so I'm adding those together. 0, 2.84, right? Yes, Rafa?
Yes.
Okay, because I'm putting these together. Here, 102.84%. So if this is, because we have a value here, right? And you said because the decade, I'm just going to try and get this one right here, right?
6.
Yeah, let's try 6. Let's see if this works. Okay, what'd you come up with?
12.
0.7? Okay, so that it's not matching, is it?
You added 2.
All right, but we look at how far we went. We didn't even do a whole decade, did we? So if we do a whole decade, how far off do you think this would be? It would be a lot different, wouldn't it? So this one is going to be incorrect. This is going to be incorrect because it's not coming up with the same values that I have here and here, right? So let's go ahead and I'm going to show you how to use all this to get per year. Every year. So right now this is in decades, but we're going to try and do it per year. And this was actually on one of our notes that we did last week. So I'm going to start off with 2 points. So my initial value. My initial value. What is my initial time? What do you think my starting time should be?
1990.
Okay, but what number represents 1990? 0. I heard it. My starting time, my initial amount, there is 0 time gone by. Okay, so what's my initial amount? Yep, 95.3. Okay. So let's go ahead and use some information that I already know. I know a couple things, right? I know that right here at 0.6, I get this value right here, right? Yeah. At 0.6, I get this value. So I know that 6 years have passed, hasn't it? Okay. So at 0.6, we get this value. So we're going to change it to years, and I'm going to show you how to do that. Because it's not the same rate. It's not the same rate. Because we can't just take it and divide it, because if I just divide it like you did, Rafa, it would be a linear amount. But this is an exponential growth. So on a curve, on a graph, it would go up like this. So it would go up slowly and increase like this. But what we did by dividing it, we went right here and said, hey, that's a straight line. But it's not a straight line. It's exponential. It keeps going up faster the further we go. Now, we're going to use these two values right here to solve my P, R, and T. So the easiest thing is my P is going to be my initial amount. Okay, so I'm going to have 95.3. So in this case right here, my rate is not the same. So I'm going to find a new rate for my time. Since I'm trying to find the new rate, I'm going to use this other point right here for my values here and my value over here. So my time is going to be what in years? This is 0.6 decades, but how many years? So I'm going to change this to 6 years. So in 6 years, what was my output? There it is, right there. So I used my initial amount to set this up, and I use this right here to try and solve for my rate that I'm going to have. So we're going to use a little bit of algebra. So I'm going to try and get my R by itself. So I'm going to get rid of my 95.3. So what should I do to get rid of my 95.3 here? Am I boring everyone to death? Because I think I am. I heard a yes. That's going to cancel these. So now, I'll put this in the calculator, just not yet. So it's going to be 110.7 over 95.3 is equal to R to the sixth value, 6 power. All right. So think about this. If this was a square right here, if this was a 2, what would I do to undo it to get the R by itself? Square root. All right, if that was a 2, I would square root both sides. So if it was a 3, I would cube root. But it's a 6, so I need to sixth root. Yeah, I'm going to sixth root. So it's going to be a sixth root in here. So I'm going to get R is equal to the sixth root, which is going to be sixth root of 110.7 over 95.3. So we're going to have to put this in the calculator now. It should be... So give me 3 decimals on this one.
1.02.
Yep. So R is going to be at 1.025. So now we have the correct rate. So we can now calculate it per year. So we can calculate it per year for this to work. And yes, you will have this question on the quiz coming up, which is probably going to be doing either Tuesday or Wednesday next week. And there's also going to be collecting your notebook at that time. For all those people that did all that extra, it's time for me to actually grade all that extra that you did. Go ahead. All right, let's see what we got here. It says, in healthy adults, caffeine has an average half-life about 6 hours. Let's suppose a healthy man consumes a cup of coffee. It contains 100 milligrams of caffeine at noon. Each of the following represents describes the amount of caffeine in the man's body some number of hours after consumption. How many hours after consumption? All right. Half-life. This is super important. If you don't know this, make sure you write it down somewhere. How much do you think is going to be left at the end of the half-life? Half. Very good. Half-life means that there's going to be exactly half at a certain time. So, and my time in this case is going to be What's my time? So I know starting out, my starting time, my initial time, the time that we're starting this out is 0. Because no time has passed, what is going to be the amount of caffeine? All right, let's do the math now. Let's do the half-life. What do you think the time is for my half-life?
6 hours.
In 6 hours, how much is left? Half. So what's half? It's that easy. So with these 2 points and the formula of P, R, T, we're going to solve for this. So I'm going to disregard this part right here because it's kind of pointless because they're making you do extra where you don't need to. So my initial, I need to write off what? 100. Parentheses. This is the value that I'm going to find. Okay, I'm going to find the R. I'm going to solve for the R here. All I know is at some rate, okay, at 6 hours, there has to be half left. So, my time is going to be 6 hours. And my end result, my output is okay, so now algebra time. I would like for you, hopefully you paid attention on that last problem, solve for R. All right, I'm gonna start working it out because I know you guys should be putting it in the calculator by now. Divide by 100. So we get, what's that, 50 over 100, which is 0.5 equals R to the 6th. So if you paid attention previously, R is equal to the 6th root of 0.5. So R should be about I believe it's like
0.89.
0. Yeah. I think it's a fraction. It comes out to be like 1 over 64. Is it 1 over 64? It's not?
I did it both ways. Unless this is wrong.
What's wrong? I'm not.
It's 4.2.
What?
And we said sixth root, right? Sixth root of 0.5 or 1/2, right? Yeah. Okay, you were right. So 0.89? Okay. So my rate is going to be 0.89. So we're writing a function for this now. So we were using all this right here. I have the rate. So what is my initial amount? 100 is equal to my rate, which is going to be 0.89 raised to the h, because this case right here says to write it in terms of h. And so let's see, this is going to be my function, right? So I'm writing a function, so that's going to be f of h. So that means that h is the variable I'm plugging in for, and this is the function in terms of h. So now we can figure it out at any single point. So let's say, for instance, if it half-life is 6 hours, and let me see, I had my first cup of coffee at 6 a.m. So my first cup of coffee is at 6 a.m. and then how much caffeine is in my system by 2 o'clock?
Oh, by 2 o'clock?
By 2 o'clock.
8 hours, right?
All right, so how many hours pass by? 8 hours. So that's going to be an f of 8 is going to be 100 and 0.89 raised to the 8. So how much coffee or caffeine is left in my system at that point?
39.3?
39.3? You guys agree? You said 3.6?
39.36.
3.6, so this would be a 4. And that's in milligrams. Gee, I put ml. Anyway. All right, you will have word problems like this on the exam coming up, so please. Okay, today is 4.2. Please make sure that goes in the basket. Like, share, and subscribe.